Hi guys, this is Prerna from Edureka and welcome to this interesting tutorial on Ethereum. Now before we move forward, let's have a look at our agenda for today. So we're going to start by developing an understanding of what Ethereum is. Then we'll move on to talk about the types of Ethereum accounts, following which we'll see what smart contracts are. Well, these contracts have been made popular in the recent years due to their implementation in blockchain. After this, we'll learn about the EVM on which these contracts are executed. Then I'll also tell you how to practically deploy smart contracts on the Ethereum blockchain under a test environment. And towards the end of this session, we'll talk about the real-life use cases of the Ethereum blockchain. These are the decentralized applications and the decentralized organizations. Now, before we start with our first topic, let me just brief you on why Ethereum is needed. Well, most of you here might already be familiar with the Bitcoin blockchain. Bitcoin is the original blockchain entity for providing a decentralized system to facilitate peer-to-peer exchange of values. Ethereum, on the other hand, came up from the idea that blockchain could be used for a number of purposes beyond the bookkeeping of financial transactions. So we can also say that Ethereum maximizes the usage of potential blockchain applications. Now coming back to our original topic, that is, what exactly is Ethereum? So guys, Ethereum is an open source distributed platform that allows decentralized apps to be built on it with the help of smart contract functionality. It was developed by Vitalik Buterin as an extension to the original core blockchain concept. Let me give you an analogy. Think of the Ethereum network as a collection of decentralized and distributed vending machines. Now you go and you put in tokens inside these vending machines and then specify the action that you want to be taken by pressing in the numbers. Now whenever each number is pressed, a certain code gets executed inside the machine. These are the smart contracts. And then a service is provided to the concerned user on the network. Now the tokens that you had put inside the machine were actually ethers. Ethers are the cryptocurrency token of the Ethereum network and they're used to pay for the transaction fees. There's also another parameter called gas, about which we'll talk later, that is used to pay for the computational services on the Ethereum network. Now since we're still talking about transactions over here, I'm sure some of you might be wondering, why was there a need to develop Ethereum in the first place when Bitcoin blockchain already existed? So I'll give you a clear understanding on how Ethereum differs from the Bitcoin blockchain on various fronts. Now firstly, both these blockchains are conceptually different from each other. While Bitcoin's core idea was to bring a decentralized digital money that is not governed by anyone, Ethereum, although a derivative, extends beyond the realm of cryptocurrencies. That is why it is also referred to as the second generation of blockchain. Now talking about the cryptocurrency tokens, Bitcoin's crypto is named after itself and it's called Bitcoin Cash, whereas Ethereum's crypto token is called Ethers like we just discussed. Now coming to the scripting language, Ethereum is a Turing-complete scripting language, whereas Bitcoin is a simple stack-based language and it is not Turing-complete. What I mean when I say the word Turing-complete is a language that can solve any computational problem by itself, given enough time and energy. Now next we come to the consensus algorithms. Bitcoin uses the SHA-256 hash algorithm, while Ethereum's algorithm is called ETH-hash. Both of these are proof of work currently. However, Ethereum will move to proof of stake in the near future as a part of its scalability plan. Now, proof of stake is still an algorithm with the same purpose as proof of work, but unlike it, where the miners are rewarded for solving the mathematical problem with the goal of validating transactions and then creating a new block, with proof of stake, the creator of the block is chosen depending on its wealth or stake. So more the number of tokens you own, more would be your mining power. Now even the coin release method of both the blockchains were different. While Bitcoin came through the mining of the Genesis block, so the first miner earned some Bitcoins as a reward, Ethereum's coins were released through initial coin offerings to raise funds for the new cryptocurrency. The average block creation time of both the blockchains vary, where it takes around 10 minutes for each new block to be created on a Bitcoin blockchain. In the Ethereum blockchain, a new block is formed in every 15 seconds. This is quite faster. Now, since we're talking about Ethereum, we have to discuss about the types of Ethereum accounts. As we can see here, there are two types of Ethereum accounts. The externally owned accounts that are owned by people or organizations, and the contract accounts, which are autonomous in nature. Now, these externally owned accounts are controlled by private keys, which are owned by individuals. But on the other hand, the contract accounts have associated contract codes, and these are triggered by the transactions or the messages received by other contracts or other externally owned accounts. Now, the contracts that we are talking about here are actually the smart contracts. Contract accounts operate on codes which are written in smart contracts. Now, the users can create a new contract by deploying code to the blockchain. Now, guys, smart contracts are basically immutable pieces of codes that run on the Ethereum network to perform a certain transaction or task. And when these contracts are running on the blockchain, they act like a self-operating computer program that automatically executes when specific conditions are met. Let me give you an example of this. A contract between two parties is written as a code on the blockchain. Now, the individuals involved are anonymous, but the contract is public to everyone on the blockchain. So when a triggering event occurs, which in this case is a bet on an ongoing cricket match, the contract executes itself according to the terms of the code. Therefore, if England wins the match, Bob will receive 10 ethers. But if England loses the match, Andy will receive 10 ethers, and both their wallets will be updated accordingly. Now, the codes in these smart contracts are written in a special contract-specific language called Solidity. A question will naturally arise over here that why was there a need to develop a contract-specific language? Why couldn't we just use the already existing languages like C, C++, Java instead? So, let's see why Solidity is preferred over other languages. Now, Solidity's syntax is very similar to JavaScript. It was developed because using the mainstream languages on a public blockchain won't really add value, because firstly, there are security requirements. You see, anything that gets recorded on the blockchain becomes immutable, so there is absolutely no window for bug fixes. And secondly, it costs money for executing each instruction on the program. So if you were to use C language or Serpent, for example, to write a smart contract, then you may end up with a very expensive contract and not even know why. If you guys want to create your own smart contract, then you can do that by using the Remix IDE. Now, this is a browser-based IDE and it's widely used for developing the smart contracts since it has an integrated debugging and testing environment. Now, here's what a Remix IDE looks like. The contract codes are written over here. This is the compile tab. Now, whenever a new line of code is added to the contract, it gets compiled automatically. This is the run tab, under which we can specify the environment, the account addresses along with the associated number of ethers, the gas limit, and the value in ways. Now, every time you write a code here, you can create a contract by clicking on the Create button. Now, guys, we'll be writing a demo contract to understand better how all of this works. But before that, let me talk about the EVM where all of these contracts are actually executed. EVM, or the Ethereum Virtual Machine, is a Turing-complete software that runs on the Ethereum network. It enables anyone to run a program regardless of the programming language, and even non-specialized programmers can create a program on the EVM. Let me tell you how all of this works. A user requests 2 ethers, for example, from the sender. Now the sender initiates the transaction message code and must pay for each step of the program that they activated, including the computations and the memory storage. Now this fee is paid in ethers, which is taken from the wallet of the sender. Then this transaction fee is collected by the nodes in the network that run the EVM. Now each and every node of the network runs the EVM to execute the same instruction, and this is how the blockchain database is maintained and updated by the many nodes connected to the network. Now all of these nodes are actually the miner nodes that execute and verify the transactions and then update the state of the accounts on the Ethereum blockchain. In turn, they're rewarded with ethers for each successful block mining. Now once the transaction is verified and recorded, the user gets 2 ethers in his wallet. Now, I'm sure some of you programmers out there might be wondering the same as what our little guy here is thinking about. That if the EVM is running the application code, then what's preventing a piece of code from running forever and overloading the network? Well, here's where the term Ethereum gas comes in. Now, gas is basically the execution fee that the sender pays for running a program on the EVM. It's called gas because the fee acts as a crypto fuel driving the execution in smart contracts. Now, every contract specifies the gas limit, which is the maximum quantity of gas that can be consumed. If you guys want, you can just go to your browser and type in the ETH gas station and click on the first link. Now here's where you can see the gas used for the current transaction. You can also see the gas price and the top 10 miners that have mined the blocks. You can see the cheapest gas price and the highest gas price, and also the confirmation time by the gas price. Now gas price is specified at the start by the initiator of the transaction. Now as the transaction starts, the gas used times gas price number of ethers are subtracted from the sender's account. So when a program crosses the gas limit, the execution reverts and the ethers are not refunded. So guys, it's very important to keep your program well within the set limits of the gas. Okay guys, now we come to the most interesting part of our tutorial, that is how to deploy smart contracts. So we've just learned that smart contracts must pay gas for the computations on the Ethereum network. Hence, if you rent the Ethereum network to run a contract, you'd have to pay for it. So before deploying an actual contract on the Ethereum blockchain, we need to experiment because we cannot afford to make any mistakes as anything deployed on the blockchain becomes immutable and costs gas. So we use testnets for developing demonstrative smart contracts, and these testnets simulate the Ethereum network with providing free and unlimited gas. So this allows the developers to test contracts without having to pay real money for their execution. Now I'll walk you through setting up a development environment so that you can deploy and test your own smart contracts on the Ethereum test blockchain. We're going to create a test environment on the Ubuntu Linux platform, and since I myself have the Windows operating system, I'll be using the Oracle VirtualBox to run Ubuntu. Now let's open the CLI. To run a network, we need a server. So we need to install Node.js and the Node Package Manager, since Node.js will simulate the test server on our local machine. NPM, or the Node Package Manager, is a command line interface program to manage the Node.js libraries. Now we'll run the following command on our terminal to install Node.js. Sudo apt-get install Node.js. We'll type in the password. It's asking for confirmation. Tap Y. And now we'll just wait for our Node.js to get installed. Now we'll also install the npm package. For that we'll use the same installation command, sudo apt-get install npm. Do you want to continue? Yes. And now we'll just wait for npm to get installed as well. Alright, let's just check the version of the Node.js and the npm that we have installed. So we'll type in Node.js-v. The version is 4.2.6 and npm-v. The version is 3.5.2. Now guys, this is not the latest version, so we need to upgrade our node packages since we need the upgraded versions for running the further commands. For that we need to install curl first. So we'll type the installation command, sudo apt-get install curl. Now curl is a tool that is used to transfer data from the server. Now we have installed curl, so we'll just pull the entire node package from curl, and for that we'll use the following link. Now note that the 6.x here denotes the version of the Node.js, that is 6, that we want to install. Now we'll install the latest Node.js package using the same installation command, sudo apt-get install Node.js. Do you want to continue? Of course I do. And now we'll just wait for our latest Node.js package to get installed. Now let's check the Node.js version. Node.js-v. The version is 6.13, so it's cool. Now let's upgrade our npm as well, and for that we'll use the following command. Sudo npm upgrade npm -g. Now -g is used for the global installation so that we can access it throughout our system. Now we'll just wait for our npm to get updated. So guys, our npm has upgraded to version 5.7, which is great. Now let me just clear the screen for your convenience. Okay, now guys, we need to run the test RPC on our terminal to deploy and test our blockchain contract. Now test RPC is a Node.js based Ethereum client for testing and development. For that we need to create a test RPC file. So we type in the following command. Sudo npm install -g ganache CLI. Now note that sudo is used so that the user has an authority over the existing files. Ganache CLI only runs when our Node.js version is at least greater than 6.11, and ours is 6.13, which looks good. So now we'll just wait for it to get installed. This might take a little while. Now to install the test RPC file, we'll run the following command. Sudo npm install -g ethereum.js test RPC. With this command, we'll add all the node packages on our local machine. So now we have created our test RPC file. Now let's run it and see what happens. Alright, looks great. The test RPC is running and listening on localhost 8545. Now guys, you can see the available accounts as well as the private keys over here, and we'll be using these for our contract deployment. Okay. Now we just open a new terminal because our test RPC is running on this one. Let me increase the font. Okay. Now next what we need to do is install the Block Explorer to help us keep track of the information on the blockchain. For that, we first need to install Git. Now Git is a distributed version control system that holds the repository of our Block Explorer in this case. So for that we'll use our installation command, that is sudo apt get install git. We'll enter the password. And seems like I already have Git on my system. But anyway, you can use the same command to install Git on your systems as well. Okay. Now we need to get a copy of the Explorer on our local machine. And so we'll use the following command. Git clone https github.com/etherparty/explorer. Now we can see that it's cloning into Explorer. Now it's basically pulling a clone of the repository from the cloud to our system. Okay, so it's done. Now we'll just change the directory to the Explorer by using the following command. cd explorer. Now guys, cd here stands for change directory. We'll just press enter, and now we can see that our directory has been changed to Explorer. Okay, now guys, if you want to launch the Block Explorer, you'll use the following command. Sudo npm start. Now this command will install all the packages on our system. Okay, so we'll just wait for it to get installed. Now we can see the Explorer running on port 8000 over here. Alright. Now guys, if you want to view the Block Explorer, you simply need to go to your web browser. I installed Chrome because it's preferable to me. And then type in localhost 8000 on the browser tab. Now here we can see the Ether Block Explorer page has been opened, and this is where all the transactions are being recorded on the Ethereum test network. So now that we have set up our test environment, Let's create a demo smart contract to deploy it on our Ethereum test blockchain. For that, go to your browser and open the Remix IDE. Now go to the Run tab and specify the environment as Web3 provider. They'll ask you if you want to connect to an Ethereum node. Click OK. Our Web3 provider endpoint is localhost 8545. Click OK again. Now guys, if this message pops up that it's not possible to connect to the Web3 provider, then all you need to do is go to your browser tab, click here and load the unsafe scripts. Now we'll go to our Run tab again and specify the environment once more. Click OK, click OK. Now we can see the associated accounts that were in our test RPC file that we created, along with the associated number of ethers as well. Okay. If you want, you can go to your file location and just open the test RPC file. Now these are all the account addresses and this is the same as you can see over here. Okay, now we'll create a demo contract so that you guys get an idea about how a smart contract is executed. Now we'll write a contract to increase and decrease the value of the variable, let's say named counter. So we'll just open a file and let's name it my contract 001. Now these contracts are basically a collection of code functions that correspond to a specific account address on the blockchain, as you can see here. So now we'll start writing our contract. For that, we'll first specify the source code version. So we'll type in Pragma Solidity version 4.1. Now guys, note that the latest version of Solidity is 4.16, but that won't be supported by our system, so I'm using 4.1. If you want, you can use 4.16. That will not really make any difference in the program that we are writing right now. Okay. Now Pragma is the instruction for the compiler about how to treat the source code. Now since we're creating a contract, we'll use the keyword contract and let's name it as my contract. Now our entire contract would be written within this scope. Now we'll specify our state variable, that is counter, with the value 5. So we'll type in uint256 counter equal to 5. Don't forget the semicolons, guys. Now uint256 is basically the type of the variable, that is unsigned integer of 256 bits. Now this creates a slot in the database that can be accessed whenever a function in the code is called. Now also note that we need to keep the state variable outside of all the functions so that they can be accessed globally. Now we'll write a function, say add, which will increment the value of our counter by 1, counter plus plus. Okay. Similarly, we'll create another function. Let's call it subtract. And this function would be used to decrement the value of counter by 1. So we'll write counter minus minus. Okay. Now note that the access modifier in both these functions is public. Guys, although public is the default modifier when no visibility is specified, typing out the function visibility is a good habit, so you should always do it. Now there are other access modifiers like external, internal or private, but we do not need to know about them right now. What we need now is a function to output the value of the counter as it changes with the functions called. So we'll just write a function and we'll name it getCounter. The access modifier is public here as well. And since this function is going to return a constant, so we'll use in the constant keyword. Return counter. Now guys, note that we must tell our function the type of the state variable it will return. So we have specified uint256 over here, since this is the type of our counter state variable. Now whenever a function is called, a small amount of gas is spent, but no gas is required when returning a constant function. Alright? So guys, we've just finished creating our very first contract on the Remix IDE. Now let's test our first contract by clicking on the Create tab. Here you can see all the three functions that we have created just now. Now if you tap on get counter, we get the value of our counter as 5. If you tap on add once and then again on get counter, you'll see that our value of counter has incremented by 1 and has become 6 now. Now let's tap on subtract twice and then again on get counter. We see that the value of our counter is 4 now. Alright. Now we'll open our block explorer to see the details of this transaction. Here, we'll just refresh it. And as you can see here, our contract has been successfully deployed on the Ethereum test blockchain. So now we have seen how the Ethereum is used as a platform to create smart contracts. Now guys, once you start creating your contracts and deploy and execute them on your blockchain, you will be ready to get started with creating full-on decentralized applications. Now we're not going to go into details of the dApp development, but I'll introduce you to what dApps are. Well, a decentralized application or a dApp is a set of smart contracts that operate on the data stored in those contracts. Now an application qualifies as a dApp only when it is open sourced, when it's decentralized, it has tokens fueling for itself, it generates tokens, and has an inbuilt consensus mechanism. Now these dApps enable direct interaction between the users and the providers, and they're comprised of various organizations that work together to create an application. Now these organizations are basically the decentralized autonomous organizations or the DAOs. Now guys, a DAO is very similar to a normal company. Now the only difference is that in a normal company, there is a third party, of course, and the rules are not enforced digitally. But the DAOs have their business decisions made electronically through the codes written in the smart contracts or through the vote of their members. Now the priority of these votes depend on the percentage of the assets that the entities within a DAO hold. Let me tell you in detail how all of this happens. People add funds to the DAO and are given tokens to represent their percentage of assets. So more you invest, more number of tokens you would hold. Now when a DAO begins to operate, the members propose on how to spend the funds, and based on the votes, the proposal status is decided. This way you do not need a third party to depend on, and hence more effective operations can take place. A number of possibly disruptive dApps have already appeared in the market and are continuously being deployed on the Ethereum platform. A few of them being YFund, 4G Capital, Storj.io, and the KYC chain. Now these are a few of the most famous dApps and DAOs that are in the market currently. YFund is a dApp that uses the smart contracts to enhance crowdfunding services like GoFundMe and Kickstarter. 4G Capital is a DAO that provides microloans for small businesses in Africa. Storj.io provides censorship-free, secure cloud storage by sharing data among a decentralized network of computers. And last but not the least, the KYC chain allows the users to maintain a private identity wallet that can be used to authenticate the identification in finance and commerce settings. Guys, with this we come towards the end of our session, so let's summarize what all we have learned in this tutorial. Now we know what Ethereum is and about the types of Ethereum accounts. We learned about the smart contracts and the EVM. We also performed a practical demo on how to deploy the smart contracts. And towards the end, we talked about the future of Ethereum. Now, if you guys have any queries or if there is anything more you want to learn about Ethereum, feel free to write down in our comment section below. With this, I take your leave. Thank you and goodbye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!